So we'll start with number 2. Problem number 2 says v squared plus 6v, and the directions told you to factor that. So you need to look at each term and determine what can I take out of both of those. Well, this has a v in it and this has a v in it. So you can pull a v out in front and you'll end up with a v left, v to the first power, each of those, plus 6. And that is it. Okay. Problem number 4 says x squared minus 9. Now there's only 2 terms here, so the first thing you should ask is there something I can pull out of both of those? Well, there's no number in front here, no coefficient, and there's no variable here. So you can't pull out anything. So then you need to ask yourself, well, what do I know about these 2 terms? Well, I know that x squared and 9 are both perfect squares, and I know that there's a minus in the middle, so that means it's the difference of 2 perfect squares. So I'm going to take the square root of x squared, which is x and x, the square root of 9, which is 3 and 3. I'm going to give 1 a plus, I'm going to give 1 a minus, or minus and plus, doesn't matter what order, and that is it. Alrighty, number 6 says n squared minus 2n minus 24. So there's a trinomial here. You should always ask, is there something I can pull out to start with? Well, there's no coefficient here, so we can't pull a number out, and there's no variable on the end here, so we can't pull an n out. So we're just going to have to factor it. So we know that since there's no coefficient, we're going to start with n and n. And then you need to ask yourself, what are the factors of 24 that can get me to negative 2? Well, factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work, and I'm back to 6 right here. So I need to find a set of these that can get me to negative 2. 4 and 6 should be the correct solution there. So we're going to have a 4 and we're going to have a 6. And because we want it to be a negative 2, we want to have a negative 6 and a positive 4. If you remember that trick I showed you earlier, this second one here, the minus tells you that they're going to be different, and the minus here tells you that the larger number, the 6, is going to be negative. Alrighty, number 8 is 4b to the 4th minus 8b to the 3rd minus 252b squared. So the first thing you should do is ask, can I pull anything out of that? Well, first of all, I know I see a b to the 4th, b to the 3rd, and b to the 2nd, so I have to do something because we haven't factored anything that has 4's here, so we need to get it down lower. So I know at the very least I'm going to be able to pull out a b, and if you notice 4, 3, 2 is the lowest exponent, so b squared. 4 and 8, we know that 4 goes into both of those, and 252, if you do it in your calculator, it goes in there as well. So we can have a 4b squared, and then in parentheses we'll have a b squared left from this, just b squared. We'll have a minus 8 divided by 4 is 2, b to the first, and then a minus 252 divided by 4 is 63, and there won't be anything left on the end there. Okay, so now we can factor that piece. So we'll still have our 4b squared out in front. We'll have our 2 sets of parentheses with a b and a b, and then I need my factors of 63. So you could always use your calculator if you wanted to, that y1 equals trick, divided by x, and you can see your factors are going to be 1 and 63. You will have 2, which does not work, 3 and 21, 4 doesn't work, 5 doesn't work, 7 and 9, 8 doesn't work, and we're back to 9 right here. So I need a set that will get me to negative 2. 7 and 9 will do that. Again, the second negative here, the second minus, tells us that the signs are going to be different. The first one tells us the bigger number is negative. So a minus 9 and a plus 7, and that should be your answer. Number 10, moving right along, says 6n squared plus 17n plus 12. So you should ask yourself, is there anything I can pull out of those? Well, 6 17 is a prime number, so we can't pull anything out of that. N squared n, and then there's no variable, so we can't pull anything out. This is going to be a slide and divide problem. So I'm going to multiply 6 times 12. We'll have n squared now, plus 17n, plus 6 times 12 is 72. And now we need to factor this. Okay, we want to leave a little bit of space in front of our n's here, because we're going to end up putting that 6 back in so we can divide out afterwards. I saw a lot of people forgetting that before. So our factors of 72 are 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 doesn't work, 6 and 12, 7 doesn't work, 8 and 9, and then 9 and 8, but we're already back to 9 there. So we need to pick a set, and it just happens that the last set we write down every time here is going to get us to where we need to be. So this time it is 8 and 9. 8 and 9 get you to 17. So we'll have an 8, we'll have a 9. The second one here is positive, so we know they're both going to be the same. The first one is positive, so both of them are going to be positives. So that's the factor, and I saw a lot of issues with our weekly reviews saying that people were done there. But you need to remember, bring this 6 back down in front and see what can I divide by. Well, this first one can be divided by 2. The second one can be divided by 3. So you should end up with 2n plus 4 and, 3n plus 4 and 2n plus 3. Number 12, a little bit tougher. It's 56 p to the third plus 40 p squared plus 49p plus 35. Well, right off the bat I have 4 terms there, so I should be thinking something like factor by parts, because I see that I can't pull anything out of this because there's no variable on the end, and every other one has a variable. And you should look and see, is there anything you can take out of all of them? Well, 49 only has 1 and 49, 7 and 7. So 7 does not go into 40, so we cannot factor anything out. So you're going to look at your first 2 here and say, what can I pull out of those? Well, what goes into 56 and into 40? Oh, so go down the list. 2 does. Does 3 go into 40? Nope. Does 4? Yeah, it does. Does 4 go into 56? It does, in fact. So 14. So right now we have 4 might work. Does 5 work? Nope. Doesn't go into this. Does 6 work? 6 doesn't go into 40. 7 doesn't go into 40. 8 does go into 40. Does 8 go into 56? Yes, it does, 7 times. So 8 would probably be a better choice. So we're going to have 8. And you'll also notice that p to the third and p squared means we can take a p squared out. So 56 divided by 8 gives us 7, and we'll have a p left, plus 40 divided by 8 is 5. We won't have any p left, and we're done with the first part. Then you check the second part right here, this second set. We need to figure out what can we take out. So 49 and 35. Well, 1, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works for 35 but not for 49, 6 doesn't work, 7 works for both of them. Okay, after that we're not going to find anything else that goes into both. So we're going to be able to take out a 7. It's going to be a positive in this case. And we'll be left with 7. 49 divided by 7 is 7. We'll still have our p. 35 divided by 7 gives us a positive 5. Some people would stop there, but we're not quite done. You'll notice that these 2 right here are exactly the same. So we can pull that out in front. We'll have our 7p plus 5 as our first part. And then you take your other 2 pieces, 8p squared plus 7, to get your second part. So you have now factored this polynomial with 4 terms down into 2 binomials. 14. We have 16 k to the third minus 8k squared minus 8k plus 4. Once again, this is a little trickier because you have 4 terms and we can't factor a variable out. But is there anything else we can factor out? Well, let's look. 16, 8, 8, and 4. If you think about that for a second, you should be able to figure out a number that goes into it. I know right away that 4 goes into all of those. So I'm going to have 4 out in front. 16 divided by 4 is 4, k to the third, minus 8 divided by 4 is 2k squared, minus 8 divided by 4 again is 2k, plus 4 divided by 4 is 1. Alrighty, so let's see, can we factor this by parts now? Looking at the first two here. Still going to have our 4 out in front. 4k to the third minus 2k squared. Pretty straightforward. You can bring out a 2 and you can bring out a k squared. And you'll be left with 4 divided by 2 is 2. K to the third, k squared means we'll have 1k left. K to the first left. Minus 2 divided by 2 is 1. K squared and k squared, so we won't have any k's left. Just a 1. Coming back to the second part, we have 2k plus 1. Well, we want this to be a 2k minus 1, so you should definitely factor out a negative 1. Negative 2 divided by negative 1 is a positive 2, and we'll still have our k. Positive 1 divided by negative 1 is a negative 1. Okay, once again, you want to look and see that these two parts are exactly the same. If you ended up with a plus over here, you'd know you'd have made a mistake because there's no way you can go any further than that. So, once we're done with that, we're still going to have our 4 out in front. We'll bring our common factor here of 2k minus 1. And then we'll bring our other two pieces, 2k squared minus 1. And you don't really need this extra set of parentheses. I just put it there because I had it in the top. So that's 14. 16, getting into something a little different. Those were all factoring problems. 16 here says state the excluded values for each. Well, it starts off as m plus 10 over m squared plus 17m plus 70. If we're looking for undefined values, or excluded values, what makes it undefined? You just want to take this bottom piece, m squared plus 17m plus 70, and set it equal to 0. So to solve this, we want to factor it. So we'll have m and we'll have m. Factors of 70 to get to 17. That should be a pretty easy one. 7 and 10. Second one's positive, so our signs are going to be the same. First one's positive, so both of them will be pluses. So we factored, now we want a t-bar. You'll have m plus 7 is 0, m plus 10 is 0. So m will be negative 7, and m will be negative 10. 18 has the same set of directions. Just check so you can still see this. Yep, move it up a little bit. So 18 says, state the excluded values again. Little tougher on the bottom. We start with 5n to the fourth minus 15n to the third minus 20n squared. None of that even matters because it's the top of the fraction and they just asked us for the excluded values. The bottom, though, is the important part. 3n, did that twice, n to the third, minus 36n squared plus 96n. So again, that top didn't matter. This bottom is what we need. So we're going to take 3n cubed minus 36n squared plus 96n equals 0. Should notice right away this is a cubed out in the front, so we need to somehow change that to make it into a squared. So at the very least, we're going to have to pull out an n, and you want to ask yourself, is there anything we can pull out of these three? Well, a 3, a 36, and a 96 are all divisible by 3. So we'll have 3n out in front. We'll have n squared left here, minus 12n, 36 divided by 3 is 12, plus 96 divided by 3 is 32. And we'll still have that equal to 0. Okay, don't lose this 3 on out in front here. Keep it out in front, and now we need to factor the insides. We'll have our n. Factors of 32 that can get us to 12. Well, 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, and 8 is right up here already. So 4 and 8 seems to be it. We'll have our 4, we'll have our 8. The second sign here is positive, so we know they're both going to be the same. The first one is negative, so they'll both be negatives. Now when we factor that, now we want to t-bar it, except for there's going to be a couple different pieces. We're going to have the 3n equals 0. We're going to have n minus 4 equals 0. And we're going to have n minus 8 equals 0. So we'll have n is 0, n is 4, and n is 8 as our three answers. Alrighty, number 20, almost done with the front. It says 20v to the 5th over 40v squared. And the directions say simplify the expression. So the first thing you want to do is just look at 20 over 40. What can we break that down into? Well, what goes into 20 and 40? I can think that 2 does. I think that 10 does. Is there anything bigger that goes into that? Yeah, sure. 20 goes into each of these. So 20 goes into 20 one time. 20 goes into 40 2 times. And now I need to look at my second part of the fraction. So look at your v to the 5th over v squared. If you recall, this was the same as v times v times v times v times v, 5 of them, over v times v, just 2. So we know we can cancel 2 of those, and we'll be left with v to the 3rd power on the top. So you should have 1 v to the 3rd over 2, or if you get rid of that 1, it would just be v to the 3rd over 2, which is also acceptable. I'm going to turn my page here. And we can move on